For Army and Marine ground support, and in order to escort the Osprey tilt-rotor aircraft, one potentially awkward-looking but useful aircraft would be to build a strike aircraft, which would be a biplane, in which both of the wings would be attached to a ring which would rotate. The wings would also have both leading and trailing edge devices, which should enable them to operate at a high angle of attack. By doing this, the wings can rotate and the aircraft itself can remain horizontal. The highly rotated wings produce better lift at lower speeds. What is called the pressure term is V squared divided by local air density, and a factor of 2. At 120 miles per hour, 180 feet per second, which squared is 32,400. At sea level, the number you divide by is 800, which is 40 pounds per square foot of lift. If that is raised to a useful tactical altitude of at least 10,000 feet, the number decreases by probably a factor of about 0.7. However, by having a high angle of attack, you can achieve what is called the coefficient of lift of between 1.5 and 2. And the fact is that you could probably achieve about 40 pounds per square foot of lift. If the wings are 9 feet chord from front to back and 55-foot span, that's about 500 feet. For biplane wings, that would be a total of 1,000 square foot of wing area, or the entire aircraft could weigh about 40,000 pounds. The biplane wings would be joined by vertical struts at the midpoint and at the edges. That enables additional redundancy in the event of battle damage. Those struts help to carry the damaged wing portion of the wing. If the wing structure, the wing spars, are broken between the fuselage and the first strut, the strut and the attachment at the fuselage will help to maintain the structural integrity of that part of the wing. It should be highly resistant to battle damage. One of the negatives is the sheer size of the aircraft. The rotating ring for the wings would have to be about 11 feet in diameter. The total height of the aircraft would have to be about 12 feet. And that is a very large surface area. It's bad for drag, and it's also bad for aerodynamic stability. In order to counter that, very large vertical stabilizers would be needed at the back of the aircraft. In order to fit it into aircraft hangars and the hangar deck of Navy vessels, the vertical stabilizers would have to be set so that their top edge is below 20 feet. Building an aircraft with folding wings would be difficult, but should be possible. The aircraft would have 2 crew members, a pilot, and a gunner. It would have the 30mm chain gun fitted to the Army Apache attack helicopter. The positioning of the gun is a little tricky. If the gun is placed at the center of mass of the aircraft will not rotate when the gun is fired. However, there needs to be additional weapon stores, which would probably be a winglet at about the center of mass of the aircraft. Additionally, the landing gear would have to be fitted, perhaps in sponsoons, at the end of the winglets, which would carry additional weapons. If the gun is placed then at the center of mass, it can only fire through the forward arc of the aircraft and could not fire 90 degrees off to either side. To have the gun fire off at 90 degrees at either side, it would have to be moved forward and would then cause rotation under fire. It might be possible to build the gun with a floating mechanism so that when it fires, the recoil is not felt until the shell leaves the barrel. This is standard for artillery pieces and some sniper rifles. That would mean that the gun would have the capability of firing one shot accurately. Under automatic fire, the gun is slewed to cover the area with fire, and its absolute accuracy is slightly less important. The engines would be mounted on the top of the aircraft, and it would be high bypass turbofans. The net top speed that is looked for is about 300 to 350 miles per hour, so that it can accompany Osprey aircraft on strike missions. It cannot go into a complete hover as a helicopter, but it can fly at relatively low speeds, which should make it a stable gun platform. Under the winglets could be carried laser-guided rockets, unguided rockets, and small bombs, up to 500 pounds. So the 250-pound small-diameter bomb and a 500-pound bomb could also be carried, and it could be used as a light strike aircraft as well. It would be fitted with a laser designator at the front end to help guide weapons, and enable to function as a light bomber as well. For takeoff, the biplane wings would be rotated, and the aircraft could take off pretty much essentially in a horizontal position. The landing gear would be one wheel in a sponsoon at either end of the winglet, which would be used for carrying weapons, and would rotate down for takeoffs and landing. An additional nose wheel or pair of nose wheels would be fitted, which would then fold up in the front of the aircraft. The aircraft would be flown directly by either the Army or the Marines, used for both long-range support, slightly beyond the range of helicopters to extend their tactical control area, and can be used as an accompanying gunship for the Ospreys by the Marines, by Army Special Operations, and can also be used to provide fire support for helicopter landings as well, and helicopter air movements. Flying at speeds of 120 miles per hour enables accurate gunnery as well as allowing effective observation of ground positions. Although it does not allow it to actually go into a hover, it can still be effective by making tight turns and maneuvering low to the ground to provide continuous support and fire for helicopter landings, and to be used independently as a light strike aircraft. By having both wings rotating together, the aerodynamic center, the center of lift, will remain relatively constant. The other consideration is that the winglet, which is carrying the weapons, and which also has the landing gear attached to it, would interfere with the airflow around the lower wing, particularly when the lower wing is rotated. It would probably not be significant enough to cause a severe reduction in lift, but it is a factor. The biplane design enables the wingspan to be reduced, that makes it fairly maneuverable and allows the wings to have struts between them to give them additional redundancy and support to make for a stronger aircraft and make it a little more compact and parking.